Hello and welcome to this course on computational mathematics with Sage Math. In the previous lectures, we have looked at how to use Python as an advanced calculator. We also explored lists, tuple, dictionaries, etc. We also saw how to use if-else conditions, that is branching. And then we also created several user defined functions, and we have also seen writing loops. So, now since we have already created several user defined functions, and we know that from a module how to import any function. So, suppose we want to create our own module or library of functions. How do we do that? So, first let me explain how to create our own list of functions. So, for that what you need to do is you simply create user defined function and put it in some file one after another and save it as .py file. So, let me just show you. We already have created several user defined functions. So, what I have done is I have copied these user defined functions which we have created so far. So, for example, we created compound interest function, we created one function for Heron's formula, for something for checking if there is if ABC forms a triangle. If it is a triangle, then what kind of triangle it is. Then we have also created user defined function to find roots of a quadratic. We also created a user defined function to check some positive integer is prime or not. We also have created user defined function to find GCD of two integers and with the name myGCD, and we also created user defined function for Newton-Raphson method. So, all I have done is just copied all these user defined functions alone in a file, and I have named this file as module.py. You can just copy these codes even in notebook and then just save that as .py. Okay. So, let us see, and of course, you need to save that file in the directory in which all your files are there, or you can save it in fact anywhere, but then while importing you need to give the path. So, let us come back to this. So, we have already saved that file which contains list of functions, user defined functions, and let us see how do we make use of that. So, what we can do is, let me simply say import my module. This is the file name I have given, mymodule.py, and this is saved in the same directory in which I am working. Okay. Now, let me execute this. So, it has imported that module, and all the functions inside that module will be available using tab. So, if I say my module and then press dot and the tab, you will see all the functions that we have created. You have functions like compound interest, Heron's, is triangle, is prime, myGCD, Newton-Raphson, solve quad, and if you look at sqrt and csqrt, these are the functions we imported inside that module. So, those will also be available, right? And how do we make use of this? So, for example, if I want to find GCD, so I can say my module dot GCD of two integers, let us say 422 and 764. The answer is 2. If I make it here minus of the, let us say 42 and this, the still answer is true. Okay. So, either you can access by typing dot my module dot the function name, or if you want you can simply import some functions or all the functions. Already you know how to do that. You can simply say from my module import this function comma this function comma this function, or if you want you can say from my module import star, so it will import all the functions. However, whenever you want to import all the functions, generally it is not a good idea, because unnecessarily all these functions will be sitting in the memory. So, we should try to import only those functions which are needed in that particular session. Okay. So, creating our own user function is very easy, right. So, all of you should just look at whatever functions we have created. You just copy paste those functions in a file and give the name, whatever name you want. You can call mylib.py, you can call mymodule.py, you can simply call modules.py, any name you can give. Okay. Now, in this lecture we are also going to look at a very important library which is called NumPy. NumPy stands for numerical Python, and it is a Python core library or module for doing scientific computation, and it contains a powerful n-dimensional array object. Let us see what are other features in this. So, before that let me also tell you, in case you are working with simple Python, if you have installed just Python program, then NumPy may not be available. So, you need to install NumPy. However, in case you have installed Anaconda, NumPy etc. will be available. So, you do not have to worry about. If in case you want to install NumPy using Conda, then you can simply say Conda install NumPy, or you can use pip space install NumPy. This will install NumPy, and once you have installed NumPy, you can import this and make use of all the functions that are available inside NumPy. We will see that this function is very useful. Now, let us just look at what are some of the features of this NumPy library. So, as I said, it is a powerful n-dimensional array object. It provides several methods that can be applied on any n-dimensional array. It has sophisticated scientific functions. It can be thought of as a tool for integrating C, C++ and Fortran codes. It is very useful for linear algebra, working with linear algebra, Fourier transforms, and also random number generations. So, it has several methods to generate random numbers. And of course, in case you have used MATLAB, so NumPy along with SciPy has very nice features and lot of features that MATLAB has. And of course, it is very useful in data analysis. So, among data scientists, it is very popular. So, these are some of the features of NumPy. We will see some of it. So, we have already seen how to generate a list, one dimensional list or two dimensional list in Python, but there were several drawbacks or limitations to this list. So, the question is, why not use Python list? Why do we want to use NumPy array? So, there are few advantages. One, the NumPy list consumes less memory, and as a result it is fast, and at the same time it is quite versatile. So, let me explain what do I mean by this. So, let us look at a function range in Python, which we have already used, but when we used range works only for a sequence of numbers which are integers, and you can have integer increments. If I want decimal increment, it doesn't work. We have already seen that. Whereas in NumPy there is a function called arange, where you can not only create sequence of integers, but you can also create a sequence with increment as decimal number. So, let us import NumPy and give it a name NP. So, we will say import NumPy as NP. Next, let us first generate a list using range function. So, if I say, let me say L is equal to range, and let us say range is from, let us say 10 to 20, or let 10 to 30, and with increment let us say 2. So, let me go up to 30. So, I will say range 20 to 30. So, this will create a list. Now, you can let me put it also list here, so that you will see as a list. This is a list, and we have already seen that instead of increment 2, if I say 2.5, then it will give me an error, because it does not accept non-integer increment. So, let us have list. So, what is L? L is 20, 22, 24 up to 30. Okay. Now, suppose we want to, let us say, apply some function to each member of this list. So, I want a list, let us say something like sine of L. So, sine of 20, sine of 22, and so on, and let us see whether we are able to do this or not. We have already seen several methods that can be applied on L. For example, you can find the length, you can access any entry, you can add two lists, and you can append, you can sort, all these things we have seen, right. So, what we want to do? So, let us say if I say import or let me say from math import let us say sine function, right, and let us say if I say sine of L, then it does not work. It gives me an error, and it says that must be real number, not list. Okay. So, sine function actually can be thought of as a scalar function. So, it takes only one argument at a time. You cannot have a list. So, that is one drawback of creating list, whereas NumPy also has all these scientific functions, mathematical functions like trigonometrical function, exponential function, logarithmic, and all these things, etc. And there it will work. We will see in a minute. Okay. So, that is the somewhat disadvantage of using list from standard Python library. Now, let us create a list using arange. So, we can say np dot arange, and then if I simply create 20 to 31 with the increment 2, again it will create the same list, but this time it is not a simple list, it is an array. Okay. So, let us see now. Let me give this name as it is array from NumPy. So, let me call NL is equal to this, and let us see we want to apply the sine function on this, whether it works. So, first we will import sine function from NumPy library. So, when you say NP and press dot and tab, then you will see several functions inside this, including sine, cosine, exponential, logarithm, etc. I mean, you can go through this list and try to explore some of it. We will make use of few of them, but there are just too many. I can't explain each and every functions from this list. Okay. So, let us call sine and apply this to NL. Okay. So, you can see here now we are able to apply sine function to this list NL, which is an array of numbers from 20 to 30 with a common difference 2. So, this is sine of 20, this is sine of 22, this is sine of 24 and so on. Of course, we know that this is sine of 20 radians. Okay. So, you can apply actually any function to a NumPy array. Okay. Let us generate another, let us also look at, if I want to generate np.arange, and again 20 to 31, and let us say this time common difference is 1.75 np, right. So, again you can see here this you can generate a list with increment as non-integer or floating point number. Okay. There is another function which is also useful inside this NumPy, and that is called linspace. So, if I say np dot linspace, this is very similar to linspace function in MATLAB. So, what you need to do is, suppose again I give 20 and 30, and suppose this interval 20 to 30 we want to divide into 10 equal parts, right. So, when you divide into 10 equal parts, then there will be 11 points inside this interval 20 to 30. So, if I write here 11, this means what will it do? It will insert 11 points including the end points. The 2 points will be the end points 20 and 30, and the remaining 9 points, they will all be equally placed. Okay. So, if I do this, what will you get? You should get 20, 21 up to 30, and that is what you have. Instead of 11, if I say give me 30 points, 31 points, then you have 20, 20.333, 20.666, 21 and so on. Instead of let us say I want 50 points, then I can say 51, you will get this. So, this is again a very useful function to generate list of numbers or list of points in the interval which are equally placed. Okay. So, so you can see what is the difference between the range in NumPy and range in Python. Range function has more facilities than the range function. Okay. So, let us also look at some of the other mathematical functions inside NumPy library. So, let me insert one input cell here. So, if I say np dot and press tab, you will get whole lot of options. You can go through all these things. So, for example, let us create a list. Let us create some list of random numbers. Okay. So, there is a module inside NumPy called random. So, let me import random, and inside this random, if I look at random dot and press tab, again you will see different functions inside, and you have one rand int which will generate a random integer, you have random which will generate a random number, you have other options, you also have sample, we have seen how to generate a sample, and many other things. You can generate random numbers based on particular distributions. Okay. So, let us generate a random int, rand int, and let us say some random int between let us say minus 10 to 10, and how many do we want? Let us say we want 20 of them. So, takes 3 positions argument, but 4 are given. rand int. So possibly let us say this is okay. Let us look at what is the way to make use of this. So we will look at question mark and then press enter. So that will give me okay. So this generates only one random integer at a time. So we will simply say minus 10 to 10, this is 1, and let us make a list of this list. How many we want? For I in range 20, this will be 20 random integers, and create a for example array of this. So we will say np dot array. So inside NumPy there is a function called array which can generate array, one dimensional array, it can generate multi-dimensional array. So we will see how to generate two-dimensional array, that is a matrix, or one-dimensional array can be thought of also as a vector. So this, let me store this in x. So this is a, so let us see what is x, print x, that is the one dimensional array. Okay. Now let us say we want to apply any scientific function to this, including functions which we define on our own, that user defined function, or any function that is inside NumPy. So NumPy functions can be operated on any array. Okay. So that is the one difference between mathematical functions inside math module and functions inside NumPy module. So if I say for example x np dot let us say mean, right. So mean of x, it will give me what is the mean. If I say np dot sine of x, it will give me the sine of each of these function. Instead of sine, I can say exponential of this, it will give me the exponential. I can say np dot and then let us make use of some other functions. For example, I can say max. So it will find np dot max of x, it will find maximum of the list, that is what the maximum is 9 here, and I can simply say, you can also say np dot arg max of x. What will it find? It will find the argument of the maximum value. So in this case 9 let us execute this, it says 8, that means the x of 8 is 9. You can check here, x of 8 is 9, correct. So it gives you the index for which that particular index is the maximum. Similarly, you can do arg min and things like that. Okay. So actually if you want to take any slice of this list, it is exactly similar to how we took slice of any list in Python. So that is exactly same. I can also say, if I want to look at what is the last number, I can say x of minus 1. If I want to find let us say x of 3 to 7, then it will give me x3, x4, x5, x6, that is all you have, and of course it will create as a array. So you can apply any function to this list, right. So we can create our own function. Let us say f of t is equal to exponential of t plus sine of t square. So of course we want to apply this on a list x, then we have to use this exponential and sine function from NumPy library. So that is why this returns np dot exponential minus t np plus np dot sine of t square. Now let us run this and let us call this function. So if I say f of x, you will see the f of each of the entry inside this list. Okay. So you can apply any function to a list which you have created. Okay. So next time we will look at how to deal with two-dimensional array, even three-dimensional array, and we will look at how to work with matrices. So there is another library inside NumPy which is called linalg module, and inside linalg you have basic functions to deal with linear algebra methods. Okay, so I will see you in the next lecture. Thank you very much.